Okay, let's look at how we can use truth tables to validate our logic and some common logic errors. So with this first program here, it's going to ask, do you have printer ink? And I'm going to enter 1 for true or 2 for false. Let me just reformat these a little bit so they look nicer. So in this case, first it'll ask, do we have ink? I can say true, or I can say false, but I'll say true for both. And it says can print. I need some extra spacing in here. Don't like these all together so close. Let's also put another new line in here. Okay, so if we say both true, we have ink and paper, then we can print. What if we have ink but no paper? It still says we can print, so that's not right. We have a logic error here. Sorry, I just like to format these so I can actually read them easier. Just gonna put in some of these. Okay. So if I don't have ink but I do have paper, it still says I can print. And what about if we don't have either? Then it says printer is out of order. So this is not giving us logically what we want. It's only saying the printer is out of order if we don't have ink and we don't have paper. But if we don't have ink, it doesn't matter if we have paper or not, it's out of order. If we don't have paper, same thing. Doesn't matter if we have ink or not, it's out of order. It's only able to print if we both have ink and have paper. And maybe you can tell what this should be just from how I phrased that last part, but let's look at it as a truth table. So here is what we have in the code. If we have ink or have paper, we can print, else the printer is out of order. So remember with our or statement or operator, adding 2 questions together, we can say, is this true or this true? And the result will be true if one or both are true. So if at least one sub-question is true, then the result is true. This is the generic version where it's just using an A and B variable. If both are true, the result of the entire question is true. If at least one is true, then the result is true. It's only false if both are false. So with the truth table, what we do is we put the 2 questions here. This is going to be the 2 questions we're asking about or. We put the whole question over here to figure out what the result is. So we have ink. I have a cat staring at me right now. What do you want, kitty cat? Okay, so we can have ink or have paper, and then this is the whole question goes over here. Have ink or have paper. She's looking at my mouse on the screen. I hope she doesn't attack my monitor. So again, no matter what our variables are, these are the possible states. Since we have 2 variables, we can have the state where both are true, one is true but not the other, vice versa, or both false. So we're gonna write those here too. I'll just write a T for true or false, false or true, false or false. Okay. And just like this truth table up here, the state is going to be the same sort of thing. If we have true or true, that results in true. If we have true or false, that results in true. If we have false or true, that results in true. And when we have false or false, that results in false. So what we're basically saying is, this question is supposed to be, can we print? Can print. So, when this question is true, that means we can print. If this question is false, that means we're out of order. So the question here is saying, can we print if we have ink, but we don't have paper? That's what these 2 signify over here. It's saying we can still print. So logically, this is incorrect. Just from kind of thinking about it, we know that if we don't have paper, we can't print anything. So this just is logically wrong. Now, if we don't have ink, because we have false here and we do have paper, Oh, my cat is messing with my drawing tablet. We do have paper. It's still saying that we can print, but that's not true. We don't have ink, so this is also a logic error. And then when we don't have ink, and we don't have paper, then clearly we can't print, and this is the only one this one is logically okay, and this one is logically okay, but there's a problem with these two. It's saying we can print if we have ink but no paper, or vice versa. So if we changed this to an and, let's see how that plays out. I'm going to try to copy this, and we'll just erase what we don't need. So with the and statement, we're going to redo the last column, but we'll still have these states over here, and we'll have an and right here. So let's investigate this. If we have ink and we have paper, can we print? Yes. And as a reminder, here's the generic table. The question with the and operator, the entire thing is only true if both the sub questions are true at the same time. If only one is true but not the other, we just get a false. And vice versa the other way, or if both are false, then we get a false result. So if we have ink and don't have paper, true and false, that result is false. False and true, that result is false. False and false, that result is false. So then what this is saying is when we have ink and we have paper, we can print. Can we print? Yes, true. So that's okay. Now, if we have ink and no paper, can we print? It is saying no, we cannot print. So this is also logically good. If we have no ink and we have paper, can we print? No, false. Okay, and we have no ink, no paper. Can we print? False. So these are logically correct. So the or statement was causing problems here because we don't want it to be able to print in these two scenarios where, we have ink but no paper, have no ink but we have paper. So then this is actually what we need to do, is an and statement for this one. So let's go back here. We'll set this to and we can test out each version. So let's say we have ink and we have paper, we can print. We have ink but no paper, printer is out of order. Don't have ink, but we do have paper, printer is out of order. Don't have ink, don't have paper, printer is out of order. So now that's logically correct. Let's look at the second example. We'll just move some things over. So this is the other one that we had in the slides where if we have cookies, why is it not resetting correctly? Well, I might have to refresh this page. But basically, we're going to have dessert if we have access to cookies or cake. So do we have cookies? True. And do we have cake? True. I'll have dessert. Okay, how about if we have cookies but we don't have cake? What says we don't have dessert? So that's a logic error. If we have cookies, we can have dessert. Okay, what if we don't have cookies and we have cake? No dessert. That's also a logic error. What if we have neither? Then it says no dessert. Yeah, and that's correct. So again, you can kind of tell what the error here is. We have if cookies and cake at the same time, then I'll have dessert. But if we're missing one of those, then it says we can't have dessert. So let's look down here and we will fill out this truth table. So these questions are going to be if we have cookies and have cake. Those are the two sub questions. And then if we have cookies and have cake, then we can have dessert. So just like up here, we're going to copy these trues and falses because these states are going to be the same. We'll just move those down here. We might have cookies and cake at the same time. We might have cookies but no cake. We might have no cookies but we do have cake, or we might have neither. Now we have our and here. So true and true is true. True and false is false. False and true is false. False and false is false. So then here what we're saying is we have cookies and cake. We can have dessert. This question is have dessert. So yes. If we have cookies, but no cake, then it says we can't have dessert. So that is a logic error. If we have no cookies, but we do have cake, it's saying we can't have dessert. So that's also a logic error. And if we have no cookies and no cake, well, then we can't have dessert, so that one is a logic error. Or, sorry, that one's not a logic error. So, we have this and, that's kind of restricting us to only being able to have dessert if we have both of these ingredients at the same time. Let's again copy these over and we'll try it with the or statement instead. So let's erase these. And instead of and, we'll do or. Get rid of this part and put an or here. Okay, so true or true, have cookies, have cake, result is true. True or false, is it true? False or true is true. And false or false is false. Ors are only false if both of these sub-expressions are false. Okay, so this one is saying we have cookies and we have cake. We can have dessert. Cool. We have cookies, no cake. We can have dessert still. We have no cookies. We have cake. We can still have dessert. And no cookies, no cake. We cannot have dessert. No dessert. So these are now logically correct. So we'll go into this code and change this to an or and test it out. Do we have cookies? Yes. Do we have cake? Yes. We can have dessert. Okay. We have cookies, we don't have cake, we can have dessert. No cookies, have cake, can have dessert. And no cookies, no cake, no dessert. So that's a way that you could use a truth table to validate your logic. And you might see these more in other classes, like if you take discrete math, which is a CS210, or when you take another programming course, because it can be really useful to be able to validate your logic. And it's very easy to make logic errors if you just haven't really studied these kind of like logic problems before.